When we're looking at dealing with expressions in algebra, expressions involving single brackets are quite a common occurrence that come up. Our ideal scenario, whenever it comes to working with algebra in any way, shape or form, is to be able to get rid of these. Now, there may be some cases where the introduction of brackets is necessary, for example, solving quadratics. But in general, for linear equations or just expressions with brackets in them, our aim is to get rid of those brackets to simplify whatever we've got in front of us as much as we can. But to do this, we have to understand where this concept comes from, and we can actually relate this to compound shapes. If we imagine I've got two rectangles here, the blue rectangles in both diagrams are equivalent area, the orange rectangles in both diagrams are equivalent area as well. Let's imagine I tell you the dimensions of the orange rectangle in this first part is 2 and 3. That would mean then that the area for that one is equal to 6. Let's imagine then I'm going to tell you that the breadth of the blue one is 3, but I don't know the length of the blue one, so let's call it x. I would know then that the area of that one is 3x. Now let's imagine I then said to you, what about the total area then? Well, the total, we know for a compound shape, is adding them together. So my total area would be 3x plus 6. Let's imagine then we'll take the same problem and we'll approach it by combining the two rectangles first to begin with. Now the dimensions are going to stay the same. The orange one's still going to have a dimension of 2 by 3, and the blue one is still going to be a dimension of x and 3 as well. However, my total length of the entire shape now is the combination of the x and the 2, so my entire length from one end to the other is actually now given by x plus 2. In order to then do the total area for that one, what I then need to do is length times breadth, which in this case is going to end up being 3 bracket x plus 2, because that x plus 2 is the full length itself. Now, one thing we know is that because I've told you the orange ones are the same and the blue ones are the same, is that the two of these are equivalent. So 3x plus 6 equals 3 bracket x plus 2. So there's the same expression given two different ways, one involving a bracket, one not involving a bracket. And what we can conclude from this is that there's a way we can expand that bracket to get an equivalent expression not involving the bracket itself. So what we want to do is explore how we do this. What techniques available for us in order to be able to achieve that. So let's imagine we pose the question, how would we expand an expression like this, which involves a bracket, without having to draw a shape every single time? I'm going to show you two methods for doing this. And I'm going to show you two approaches for it. Remember, the rule is that you pick the one that works best and resonates for you. There is no one single correct way when it comes to this. There are multiple. The key thing is you understand what you're doing and you get it right. So the first method, what I'm going to show you, is what I like to call crab claw. So I'm going to take my 6 bracket x plus 1, and what I'm going to do is I'm going to draw two lines on it, like that almost make it look like a crab claw. Now each of these lines mean the same operation. Each of these lines means multiplication. When we get rid of the bracket, the rule that you need to remember with this one is if that line touches an element within the bracket, it multiplies by whatever's outside it. So it links the two elements and it multiplies them together. So the first line will tell me I'm going to do 6 times x. Nothing touches the plus in the middle, so that stays the same. And then I'm going to do 6 times 1 is my second element. And then, like any algebraic expression, what we want to do is get rid of the multiplies. So 6 times x becomes 6x, 6 times 1 just becomes a 6. So there you go, I've expanded it and I've got 6x plus 6. Now there is a second method I'm going to show you, and that's where we can involve a table. Now to involve the table, for this one, I'm going to make the table 2 rows by 3 columns. And the reason I'm doing that is there's one element outside, 2 elements within the bracket. Now when I fill in the table, I always fill it in the exact same way. I'm going to put a multiplication in the top left, that's just to indicate the operations that are going to be involved. I'm going to put the bracket across the top, so I'm going to put x. But what I'm going to make sure I do is I'm actually going to take the signs with them. So the bracket is x plus 1, so my top row is going to be an x, and then the second column is going to be plus 1. Now ultimately this is going to deal with any issues that may occur with signs in the long run, so it's an easy thing to do. The column, the element from there, is then whatever's outside the bracket, which is a 6. Now that multiplication in the top left indicates what I'm going to do in each area we go to. Each element within it is going to be given by the product of that column and row. So for example, this first box that's here is going to be given by the product of 6 and x, because that's the row in the column, and it's going to be 6x. Second element is going to be given by the product of 6 and plus 1, which gives me a plus 6. So therefore, that means that I can get my final expression with that bracket of 6x plus 6. Notice the two of these are the exact same, so they're equivalent to one another. So there's two different methods of doing it. Two different methods of doing the exact same thing. And it works every single time as we're working it through. Even when we've got negatives in the bracket. So let's imagine we'll look at the two methods. So imagine we do a crab claw method. So 8 bracket 3x take away 5. I'm going to do my lines for my crab claw. Now remember, each of those lines indicates you're multiplying the two elements that it links together to one another. So the first line tells me I'm going to do 8 times the 3x. Nothing's touching the minus in the middle, so it's going to be a minus there. Second line indicates that I'm doing 8 times 5. What I can then do is simplify, get rid of the multiplications, and have my final solution. So 8 times 3x gives me 24x, and then 8 times 5 gives me 40. So it's 24x, take away 40. If I were to approach this using a table, again, because of the number of elements I've got, I'd do a 2-row, 3-column table. Top left, again, is going to be a multiplication because that tells me the operation I'm doing. Top row is going to be the bracket, so in this case my first column is going to have 3x. Then my second column is going to be the next element of the bracket, but remember we take the sign. So in this case it's going to be take away 5. Again, this will deal with any sign issues that will come up later. Column becomes whatever's outside, which is the x. Then we do what we did before. Each box is the product of the row and column it lies in. So the first box here will become 24x because it's 8 times the 3x. Then the second box is given by 8 times the minus 5. 8 times minus 5 gives you take away 40. So then my final solution is 24x take away 40. Again, the exact same solution. I've got two different ways of doing it, two different ways of getting the exact same solution. Both work fine and dandy. Now I said the table helps with signs, and that does come into play as well, particularly when there's negative numbers outside the bracket. But it doesn't mean that we can ignore crab claw. It'll still work as well. So let's imagine I've got this one here. Negative 2 bracket 2x minus 1. So my coefficient of the bracket is a negative number in this case. So if I were going to do crab claw, the general technique would not change at all. I'd still have my lines, which indicate my multiplication operation. I would just have to remember that I'm multiplying by negative 2. So I'd have negative 2 times the 2x. Nothing touches the minus. And then I'd have negative 2 times 1. So in this case, I'd get negative 4x. Take away, well, negative 2 times 1 is minus 2. Now in this case, we have to go one step further because this part here in the middle, the minus minus, has to be sorted. To end up with negative 4x plus 2. If you manage to sort that minus minus to begin with, before having to jump between these extra two lines here, that's fine. Great, go for it. If not, you have to remember and sort it there. Now if I were to use the table method and what I did before and follow through the same steps with my multiplication here, my bracket going across the top and again taking in the signs, and then the same for the second row, but this time it would be minus 2 because my number's negative, I would still follow the exact same way of doing it. I'd still follow negative 2 times 2x. I get negative 4x. But my second box would become negative 2 times negative 1, which becomes a positive 2. So it would then be plus 2. So I've dealt with the sign there in the table so that I can then write my final expression out, negative 4x plus 2. So there we go. That's what it would become in this case. So two different methods for the same one. So what I want you to do is I'm going to put up some questions now. I want you to pause and have a go at them and then come back and check what you've done. So this first one here, expanding the following brackets. What you should end up with in this one, if I was to use crab claw on it and do this, I'd get 6 times 4x, take away 6 times 1, so I'd end up with 24x, take away 6. Now again, you should get the exact same answer if you use the table, and if I use the table method, my table would look like this. So my top row would be 4x, and I'd have a takeaway 1. My coefficient outside would be 6, and then following the rule that we did before, if each element is the product of row and column, I'd end up with 24x, take away 6. So that there is the exact same answer as what I'd get here. Second one here, 2 bracket 3 minus 5x. Now none of the technique changes just because the letter term is second in the bracket and after the sign. Our general steps stay the same. So if I were to do crab claw, that would all still hold the exact same. I'd start by doing 2 times 3, using my first line. Nothing's touching the minus, so that stays the same. And then I'd have 2 times the 5x. And when I simplify it, I get 6 take away 10x. If I were to use the table and set it out in this manner here, my top row would become 3, and then my second element in that would be minus 5x. My coefficient outside the bracket would be a 2. So first box, product of row and column, would be 6. Second box would be 2 times the negative 5. So I've got minus 10x there. So that, again, is the exact same as that. I've got the same solution. Last one I've got here, when I've got a negative outside the bracket, again, if I'm using crab claw, so we'll do that one here, I'll end up with negative 4 times 3y. The plus stays the same, and I've then got negative 4 times 2. So negative 4 times 3y is negative 12y. I've then got plus negative 8 from the negative 4 times 2. So that'll give me negative 12y, take away 8 when it's simplified. Again, if you simplify the plus minus straight away at this stage, great. If not, take the extra line to do it. Now remember, if we use the table method for this one, we set it up as we would expect. So I've got 3y, I've got a plus 2, and my number here is a negative 4. It would deal with the sign straight away. So I'd end up getting negative 12y minus 4 times plus 2 would give me minus 8. So it gives me the exact same answer there, just in a slightly different way by dealing with the signs immediately. So two fairly straightforward set of steps and methods in order to do the exact same thing. Both work, both are valid. Make sure you pick the right one for you. So what are the rules when working with this? Well, the rules are quite straightforward. Firstly, determine the method that feels best for you, that suits you best. Remember, crab claw, we have to multiply each term inside the bracket by the term outside. Remember the lines touch? That's what does it. Using a table, remember to take the signs into the table to aid with dealing with sign calculations when it comes through it. So your minus, minuses, etc. When it's expanded out, we have to simplify it when it's needed. So gather together any other like terms and make sure that they're there. We have to ensure constants and letters stick together appropriately when doing this. And the big thing at the end, again, I've mentioned it already, I'm going to mention it again because it's an important part of what we do. Always remember to sort signs. Never ever forget that, because that is vital to expressing it simple. Bear these all in mind when you're doing this, and it becomes a straightforward thing and a straightforward skill to master. Just remember, think smart, solve fast.